Today we are going to learn recursive function in C. Let us start with introduction. First of all, what is recursion? Recursion is a process of function calling itself. But why would we require to use concept of recursion in C program? To better understand this, consider the example of calculating factorial of a number. It is defined as n factorial is equal to n into n minus 1 into n minus 2 up to 1. Above expression can also be defined as n factorial equal to n into n minus 1 factorial. In situation like this, where function is defined in terms of itself, we can use the concept of recursion. It is important to note that terminating condition for recursive function needs to be defined, otherwise recursive function will lead to infinite loop. For example, in case of factorial, terminating condition would be n equal to 1. We will further discuss this part in more detail when we reach to program section of a lecture. Let us move on to the next part of recursion, that is types of recursion. There are basically two types of recursion. Number one, direct recursion. Number two, indirect recursion. In case of direct recursion, the function will call itself directly. Consider the example shown here where fun function's definition contains function called to itself at some point in a code. In case of indirect recursion, function will call another function and that another function will call the first function. Consider the example shown here where function 1's definition contains call to function 2 and function 2's definition contains call to function 1. Hence, ultimately function 1 is calling itself by means of function 2. This is called indirect recursion. Next, let's move on to the program to better understand the concept of recursion. This program calculates factorial of a given number using recursive function. Let us start with execution of program from main. Before starting execution, I would like to point out that return type of factorial function is long integer. The reason to take long integer instead of integer is that even for smaller number like 10, the factorial would be 36,28,800, which is out of range of integer. To store a larger numbers like this, we have to take long integer as a return type. Moving on to the first line of main, we have integer n, which declares the n variable to store the user input. Similarly, next line declares the f variable, which will store the calculated answer of factorial. Next we have clr_scr, which simply clears the screen and removes the output from previous execution. As of now, we will have the output screen like this, an empty screen. Next is a printf which prints the message shown here. After execution of this statement, output screen would look like this. Next we have the scanf statement, which as we know will take input from user and store it in n variable. Suppose we take input as a 4. Upon entering the number and pressing enter, we will encounter output screen as shown here. Upon execution of statement, it will jump to line number 19, which is first line of function definition. Executing a statement will check the condition, which is 4 is equal to 1. Since value of n is equal to 4, the condition is false. Hence, we will again execute the statement return n into factorial n minus 1, which will result in return 3 into factorial 2. Again, return statement 3 into factorial 2 contains the factorial 2 function call. So we will again move on to statement number 19, which is n is equal to 1. In this situation, again the condition will be checked 2 is equal to 1, which is false. So we will again execute the statement return n into factorial n minus 1, which will result in return 2 into factorial 1, which again contains the call factorial 1. So we will move on to the statement number 19 and check the condition if 1 is equal to 1. Since this statement is true, we will return value 1. Now at this point, if we talk about terminating condition, which is n is equal to 1 here, if this condition was not here, in that situation what will happen? The next function call would be 1 into factorial 0. Then next function call will again be 0 into factorial minus 1. Then next function call will be minus 1 into factorial minus 2. And so on. It will continue to move on to the infinite loop and we wouldn't have the answer. So that is why terminating condition is important. Now, since we are returning value 1 to factorial 1 function, it will be replaced with 1. Since we have two integer values 2 and 1, we will return the value 2 into 1, that is 2, to factorial 2. Again we have two integer values 3 and 2, so we will return 3 into 2, that is 6, to factorial 3. Again two integer value 4 and 6, 4 into 6, 24. So finally we will return 24 to the main calling function factorial 4. Next statement is printf statement, which will print the answer. So our output window after this statement would look like this. Factorial of 4 is equal to 24, which is the correct answer. Finally, getch will be executed, which will again bring the output window and display the answer. And that is the end of program. Next slide displays the list of functions that can be solved using recursion, which are Fibonacci series, Ackermann function, quickshort, mergesort. Both Fibonacci series and Ackermann function can be defined in terms of itself. Similarly, both sorting method quicksort and mergesort also follow recursive approach and hence can be solved by using recursive concept. So that is it for today's lecture. If you have any question or query, leave it down in a comment section. I will try to answer all queries and questions. Thank you.